Hi everybody. In this video we are going to talk to you about the curriculum content that we have for Unit 1, the universe. And we will be going over phenomena, investigations, and activities you can do for this unit.
All right, really excited to talk to you about phenomena, which is how students engage with real life situations and things that they can actually observe. Phenomena should be introduced, but don't over-explain. You don't want to tell the students what is going on. You want them to begin to record observations and start to ask some questions. And then you take those questions and you're going to start refining them with the students. Students can work together or independently when they're refining the most relevant observations and questions. A bonus kind of thing to do if you have time with these students is then to take that phenomena that you looked at and observed and then do some research or some investigations to answer those questions. So that's kind of our perspective of how to deal with phenomena. Investigations are a little different. You need to engage them by introducing maybe some sort of purpose or goal, but remember, don't over-explain. You want students to be really engaged with inquiry as much as possible. And as the year goes along, you might want to give them even more agency with these investigations. Make sure that students are generating research questions and or hypotheses, and then allow them to have a hand in planning and carrying out these investigations. It's really important in these investigations to analyze and interpret the results, which we can call data, and then to construct explanations and make claims using evidence. So if you have time, like a bonus thing, you can have students actually write reports in a lab report style to communicate this information, or a different style. It's really up to you, but we're going to provide some resources for you, so this will be really easy for you to get started with. The first kind of big thing in the universe is the Big Bang. The phenomena that we want to start with is cosmic background radiation. This ever-present microwave radiation that is the remnants of the Big Bang. So we want to get students to kind of learn the story behind that. So you'll have a resource there that not only includes some audio files, but also some visual files and a little bit of background for students to kind of learn what they're listening to, but not really give them all the answers, right? Because you want them to be able to observe and think about, what is this? Why is this happening? Again, we also want to look at some light spectra from stars, thinking about what we can see through a telescope and give them the realest materials possible. So you're going to see actual light spectra from stars that students can then later analyze in the activity. So in that activity, students will be analyzing light spectra from stars, and what they'll find is that many of these stars and galaxies are actually moving away from each other, which gives them some evidence to really consider what is happening in our universe and where it began with the Big Bang. Next, we want to talk about the sun. This is a really cool phenomenon because it's something we see every day. And our sun is our central star. So one of the phenomena that you'll show them is real-life footage of solar flares taken from a telescope. Again, we want things that are not necessarily computer-generated, but are real-life visual imagery. There's also sunspots. So this is sunspots we can observe through telescopes, but also we can look at patterns, and that's another phenomena that we can ask questions about and make observations of. And then also the masses and lifetimes of different stars, comparing our sun with the different stars in our galaxy and in our universe. And then those three phenomena help us think about, where does the energy from stars come from? And so the activity is actually a modeling activity, which you can do not only digitally, let's say if you're in a distance learning situation. These can be virtual models, but also these can be physical models that they can build or draw. So this is a very important next generation science standard, which is modeling and understanding the energy that stars are creating using this process of nuclear fusion. The moon is another thing that our students are interested in because they can see it. So those are our two big observations the phenomena is the moon observations. They're going to keep a moon journal. So for a whole month, they're going to be tracking what do they see? What is the relationship between the time of day and the moon and the direction of the sun, and the angle, and comparing that to the moon? So what are these observations? They're going to be taking observations of this phenomena. And of course, like all phenomena, asking questions about what might be going on. Mm-hmm. There's also tide pictures showing them the difference in tides, and looking at the tide calendar and thinking about how can we predict the tides and what is going on here. So of course we're talking about gravity and orbits, right? Mm-hmm. So the investigation, this is our first investigation, will be asking a question about the relationship between mass and distance in determining an orbit. So there's a game that's actually really fun. It's a computer game that students love playing around with. It's the orbit game. And it kind of gives them a sense of what an orbit is and how mass and velocity and distance are all related in calculating orbits. There's a very challenging investigation here where they're going to be writing a hypothesis. If your students have never done this before, there will be examples, and your students can actually choose one of these hypotheses. Mm-hmm. And then they will get a spreadsheet, a Google Sheet. And a lot of students struggle with this, so I highly recommend going through it slowly. So you can see in this image here, there's an example Google Sheet, and work with them to enter in the data to help launch some sort of satellite, which is you need to understand the mass of the planet that is going to be orbiting, as well as the height of that satellite, and then some more information so you can determine the answer to your hypothesis, which might be how does the distance from the planet affect the orbit. Yes. So that is an investigation because they have a hypothesis that they will either choose or write, and they will use an investigation and data to help solve it, and then talk about what evidence they're using to solve it. So this also is computational thinking. There's mathematics in here. Yes. So it's challenging, but it's really important that they're able to do these things. Mm-hmm. And then finally, space travel. Stuff that really the kids love. And this one, to be honest, it is optional because it's not as embedded in the next generation science standards, but it's so critical because this is something that's happening more and more. To understand NASA missions, SpaceX, and Blue Origin, we're going to include some videos that you can use as phenomena to show what these both federal and private companies are doing and thinking about what to do in space. And the activity is actually a discussion. So we have some discussion protocols that we're going to talk about in another video, and how you would discuss the pros and cons of space exploration in your classroom. So that's pretty much it for the universe.
Awesome. And these activities and these investigations and phenomena can be edited and used kind of how you see fit for your specific teaching environment.